Now let's explore the cosine function. Okay, let's start by determining the domain of the function. As you can see, the function exists at all points on the x-axis. So that means that the domain is the set of all x's such that x is an element of the set of real numbers. For the range, we shall have the possible values of y. So we can see that the values of y can be found at the closed interval from -1 to +1. So that means the range is the set of all y such that y is greater than or equal to -1, but less than or equal to +1. Now, to determine the amplitude of the cosine function, we have here the midline. Then we get the maximum value. Okay, the maximum value occurs at this point, and this line contains the maximum value. Now, below we can find the minimum values. Okay, based on what you can see visually, the distance of the lowest value or the distance of the highest value is 1 unit. Now, algebraically, we can get the amplitude, getting the average of the absolute difference of the maximum value and the minimum value. So we shall have 1/2 times the absolute value of 1 minus -1. So simplifying the expression, we will have 1 plus 1. Then we will have 1/2 times 2. Simplifying, we will have 1. So we can see that the amplitude, okay, is really equal to 1. Okay, so amplitude 1 unit. Now, what about the period? To determine the period of the given function, we trace from this point. We shall have the tracing going down. Then we have up. Then we will stop at this point because after that, the pattern will be repeated. So the horizontal distance from 0 to 2 pi is 2 pi. So therefore, the period of the cosine function is 2 pi. Okay, there is one complete cycle. So the frequency, okay, in the interval from 0 to 2 pi, there is one complete cycle. Now let's explore the transformation of cosine function depending upon the values of the variables a, b, c, and d. Now remember that the general form of the cosine function is f of x is equal to b plus a cosine of cx plus d. So just like the sine function. Now, what if the value of c is changed from 1 to 2? Okay, looking at the graph, we shall have the green curve representing or illustrating f of x equals cosine x, while the orange curve illustrates g of x, which is equal to cosine 2x. Now, for the domain of both function is the set of real numbers. So it's equal to the set of all x's such that x is an element of the set of real numbers. Both of these functions have set of real numbers as the domain. The range also is the same. For both functions, you will have the range as the set of all y such that y is greater than or equal to -1, but less than or equal to positive 1. For the amplitude, now as you can see, the midline of the two functions is the same, and their maximum value is also the same, which is at 1. The minimum value is also the same, which is -1. Now, counting the units of the highest value, the line containing the highest value, we will have 1 unit, same as the distance of the midline from the line containing the lowest value, or the minimum value. Okay, algebraically, we can get the same answer, which is 1. Amplitude of the given functions are both 1. Okay, now what about the period? So for cosine x, the period is 2 pi. Okay, this is for f of x. We will have 2 pi. What about for the function g of x, where we have cosine 2x? Now take a look. In the interval from 0 to 2 pi, okay, let's trace. From 0 to 2 pi, g of x will have how many complete cycles? Let's see. So we trace going down, then up, we have 1 complete cycle. Then we have another from pi. Let's trace. Okay, this is another complete cycle. Hence, we say that the function g of x has a shorter period. Okay, because in the number of in the interval from 0 to pi to 2 pi is 2. To get the period, we have to divide 2 pi divided by 2. That will give you pi. So that means the period of g of x equals cosine 2x is pi. So let us check the graph. From 0 up to pi, we can have a complete cycle. So usually we can say that the period of cosine 2x is pi. Okay, now what if the value of a has changed? From 1 we have 3. So take a look at the graph. Now as you can see, the domain of the functions g of x and f of x are both equal to the set of all x's, such that x is the set of real numbers. Then for the range, okay, for f of x, the range would be the set of all y's, such that y is greater than or equal to -1, but less than or equal to +1. However, in g of x, we can see that the range is the set of all y, such that y is greater than or equal to -3, but less than or equal to +3. It also follows that the amplitude of g of x is different from f of x. So if we get the amplitude, algebraically, we can just, okay, we know that in cosine x, we have 1 for the amplitude. For g of x, we can have 1/2 times the absolute value of the highest value or maximum value minus the minimum value. So that will give us 1/2 of 3 plus 3. That will give us 1/2 of 6. So we have 3 as the amplitude. Now, if we will graph the midline and check how far is it from the maximum value or from the minimum value, we can also see that, we can also see that it has 3 units, or the distance of the midline from the maximum value or the minimum value is also 3. Okay, we count from the midline 1, 2, 3. There are 3. Going down, we also have 1, 2, 3. So hence, changing the value of A will mean a change in the range and the amplitude of the given function. Or if we will have cosine x as the baseline, there will be an increase in the amplitude, okay, including in the range. Is the period different? Okay, so the period, does changing the value of A affects the period? So let's see. From 0 to 2 pi, for cosine, we have one complete cycle. What about in g of x equals 3 cosine x? From this point, going down, okay, then going up, we have one complete cycle. So that means both functions g of x and f of x will have a period of 2 pi. Now, what if there will be a change in the value of b? If b is -2, take a look at the orange curve. It is 2 units below the cosine function. Okay, so the domain is the same. The domain is the set of all x's such that x is the set of real numbers. Of course, the range is also affected since we have a change in the maximum and minimum value. So y would be the set of all, or the range is the set of all y such that y is greater than or equal to -3, but less than or equal to -1. What about the amplitude? So is it still the same? Let's see. The highest is -1, or the maximum value, while the minimum value is -3. We get the average. Okay, we're multiplying this by 1/2. So we will have 1/2 of -1 plus 3. So therefore, we will have 1/2 of +2. So the amplitude is still the same. Amplitude is still equal to 1. Okay. What about the period? The period is still the same, which is 2 pi. Okay, so we will have one complete cycle up to this. So this will be 2 pi. Of course, the frequency is the same. Now let us see the effects of changing the value of d in the given equation. So let's say we have cosine of x minus 6. So take a look at this. Originally, we have here the y-intercept. Okay, this point is at 0, 1. Now, here in g of x, the maximum value occurs at 6, 1. Okay, so we get the difference 6 minus 0, then that will be 6. So therefore, the graph of the function is shifted horizontally to the right 6 units. The domain and the range are still the same. The amplitude is the same. The period is the same. Only that it was shifted to the right by 6 units. Going back to the general form of the cosine function, we will have f of x equals b plus a times the cosine of c of x plus d. The value of a gives us an idea of its amplitude, while the value of c, its frequency, and b, whether it's shifted downward or upward, and t, whether the graph is shifted to the right or to the left based on the original function cosine x. Remember that to get the exact number of units of horizontal shift, we have to divide d by c.